First week is 0 to 7, second week 7 to 14, third week is 14 to 21. I'm talking about the end of the fourth week, meaning it is from 21 days to 28. So end of the fourth week will be 26, 27 days. Is that clear?
Yep.
Okay. What happens at that time? The paraxial mesoderm, this is the story about the paraxial mesoderm, will be under the influence of some gene, and I'm going to write those genes, name of those genes, that there will be some changes will happen. Now paraxial mesoderm, many people also call somites, S-O-M-I-T-E-S, somites. It's the same thing. It has three parts. The somites, I did not tell earlier, but now I'm telling you. It has three parts. One is called sclerotome, which will form the vertebrae. You know that. And then another one will be myotome, which will form the muscle. And a little bit part will be forming the dermatome. So it has three parts. Together it is called somites. Is that clear? So one more time. The musculoskeletal system will not work unless you have a little concept of the paraxial mesoderm. Everybody knows by now paraxial mesoderm is situated just by the side of the axis, which is by the side of the notochord at that time. And I told you at that time it forms the muscles and the vertebrae. Now I'm telling you that it has three parts. And the part paraxial mesoderm often it is called somites, S-O-M-I-T-E-S, somites. It has three parts. It is called sclerotome, myotome, and the dermatome. Now what happens is these three parts are there. Under the influence of the gene, they start moving. The one which doesn't move is the sclerotome. It does not move. But the myotome and the dermatome, they move. They move towards the skin, because you know by that in my diagram you can see that it has three parts. So let me draw that part. I'm talking about over here. So if I do this part, it has three. 1, 2, 3. Like Mercedes. 1, 2, 3. Three parts. 1, 2, 3. Three parts. One is called sclerotome. One is the myotome. One is the dermatome. But then I say that the sclerotome, for example, let's put it this as a sclerotome. This doesn't move. This doesn't move. But these two move towards this direction. Towards the skin. Okay? Towards the skin. So it was in the center. Visualize that this is the coronal section.
Okay.
Okay? So the head is over here and leg is over this side. So it's a section over there. And right in the middle you have this, and it is moving towards the periphery. When it touches over here, okay, there is a special name. You have to underline that name, and it is called apical ectodermal ridge. Very important. AER.
What is that?
Apical ectodermal ridge. When it touches over there, which will touch the myotome and the dermatome, that basically is moving, and something is happening over here. That is the development of the limb. When it touches over there, ridge, you can understand the meaning of ridge. R-I-D-G-E. Apical ectodermal ridge. Apical means it will form like pushing like an apex. So this area will look like a little bit apical ectodermal ridge. You are okay? So one more time. The paraxial mesoderm is also called somite. It has three parts. Sclerotome, myotome, dermatome. Sclerotome doesn't move. So it is forming the vertebrae. Sclero means, it is like a bone type of thing. But the other two, myotome and dermatome, will slowly move towards the periphery and towards the ectoderm. That's why it is called apical ectodermal ridge. When it touches there, then the genes are expressed and the limb starts developing. In the exam we ask that what is the starting point of the limb development? Your answer is AER. The other things are there, but there is no limb development unless it touches over there. When it touches, and it touches in two places. Who can tell me that the touches in two places? Give me the two places where the limb should be developed. Yeah, vertebral level, which level?
S2 to L4.
One is cervical level, one is the lumbar level. You understand that? When the cervical level is touching, then this is forming. When it's touching over here, then. So what will happen is, so this one slowly will grow, and this one slowly will grow, and that's the limb. Are you okay? So that is in reality what is happening, that apical ectodermal ridge. Apical ectodermal ridge is forming in two places. One is the cervical region, where is the brachial plexus, we'll go through that. And one is the lumbar plexus, we are doing now lumbar plexus, where the apical ectodermal ridge will be formed, and it will form the lower limb. Lower limb and upper limb. But the important point the students must understand that it can be initiated by the formation of the AER. AER is the crucial name. You cannot forget it. Remember the AER, apical ectodermal ridge. And how it is forming? Because of the migration of the cells. And when it is touching over there, some genes are expressed. So I'm going to give you some genes which are expressed at that time. Okay. What are the genes are expressed over there? Number one, please remember we have two hands and two legs. So there's a gene is called homeobox gene. Homeobox. I'm just writing it. You don't have to know detailing of that, but this is just an understanding, homeobox gene. Because then we need in two places. That gene should be expressed in two places. So two legs and two hands. Second thing is that we have retinoic acid. That is retinoic acid. Then we have many connective tissue will be formed over here. So we need fibroblast growth factor. Fibroblast growth factor. Some people say yes, sonic hedgehog gene. I asked you a question over there. Sonic hedgehog gene is also, SHH gene is also responsible for that. So many genes are there. And I have a slide for that. You will see that same thing is written over there. Okay? Now do you have to remember everything? Yes, you remember this thing because these are not new to you. I gave you already the genes which will be doing all the system. Now it's coming up again. This retinoic acid will come back again in the GI. In the GI system, retinoic acid is the most important factor. So some of them are gene, some of them are factors. Like fibroblast growth factor, we don't call it a gene, but basically it expresses the gene. And we will start. So what will happen now, when the genes are expressed, it starts giving the apical shape, like it will be projected out, then the muscles can go in, myotome. You got it? And in my drawing, you can see that this one is the lateral mesoderm. Remember that? That goes over there. Lateral mesoderm also, which will form the bone. So the bone of this one, if I say the fibula, maybe I will ask this question. I got a question. The question is, if I see the upper limb, which is the radius and ulna, or the humerus, this is a bone, B-O-N-E bone, coming from where? Lateral mesoderm. It is not from the sclerotome. Sclerotome it does not move. So it is forming the vertebrae. But over here, you can understand how it is. This goes inside. and forming the, so your hand has, the leg has, bone, muscle, connective tissue, and the nerve and other thing. Nerve means ectoderm, so no question about that. Brachial plexus, this and that will go in there. But your question is, okay, I understand that apical ectodermal ridge is forming, which is pushing it. Say apical ectodermal ridge. I don't want to spoil this one. This is, I just bought it. Anyway, think about it. So, you got it? So, apical ectodermal. So, it will be increasing in shape, but then inside, the muscles and the bone will be formed. Yes or no?
Yes.
Muscle is, and the bone, muscle is coming from the myotome, everything, and the bones are coming from the lateral